In this module, we discuss the Parseval's relation for continuous time Fourier transform. And basically, Parseval's relation tells us a different way to compute the energy in the signal. Let us prove this relation. And to prove it, we start from the left-hand side. Minus infinity to infinity, magnitude of xt square dt. We can write it down as xt multiplied by x conjugate t dt. And now we replace x conjugate t by its inverse Fourier transform. Here is the relation for the inverse Fourier transform. We do the conjugation on both the sides and put it in this expression. So we have minus infinity to infinity xt, and here 1 divided by 2 pi, another integral x conjugate j omega e, j omega t after conjugation will become e minus j omega t d omega. So this whole thing inside the bracket is x conjugate t dt. And then we replace the order of these integrals, bring 1 over 2 pi outside, minus infinity to infinity, x conjugate j omega, minus infinity to infinity, xt e minus j omega t times dt and d omega. And you notice that this bracketed term now is x j omega. So we have our proof, x conjugate j omega multiplied by x j omega is magnitude x j omega whole square d omega. This relation says that there are two different ways to compute the energy of the signal. So either we first compute magnitude xt square, which we can refer to as energy per unit time, and then we integrate the energy per unit time over all time t. And in the second method, we first compute magnitude x j omega whole square divided by 2 pi, which we can call energy per unit frequency. And then we integrate the energy per unit frequency over all the frequencies, and this is also equal to the total energy in the signal, and this is the total energy in the signal. Because magnitude x j omega square tells us energy per unit frequency, therefore the square of the magnitude of the Fourier transform, sometimes we refer to it as the energy density spectrum of xt, because it tells us the amount of energy concentrated at different frequencies in the signal.